Hey everybody, welcome back. Today we're going to have some more application fun. These are going to be really similar to the problems that we've done in the past. The only difference is instead of given the total cost or being given a final answer for it and we're solving for X, we are actually going to be writing an equation that represents any situation. So if we look at our first example, it says, lucky you were just hired to work at Walmart. They have agreed to pay you $7.75 an hour. Letter A is asking us to write a function to represent your earnings, and it tells us that f of x represents your total earnings, and x is the number of hours you have worked. So if we go back and look at our original equation, it tells us that they have agreed to pay you $7.75 an hour. We haven't seen too much of that terminology in other problems, but it's the same as your per or your each. Same type of word. So that word tells us who gets our x. So we have a 7.75 with an x. If you look back at that problem, it does not give us any other numbers. So we need to figure out where that f of x goes to. Well, your total earnings is equal to how much you get paid per hour and how many hours you work. So we simply just say f of x is equal to that 7.75x. Now that we have our equation written, we can go ahead and answer the questions that follow. In this situation, it wants to know how much you get paid if you work 22 hours. All we're going to do is take that 22 because it's in the x position, and we're going to put it in place of x in our equation. So our function evaluated at 22 hours is equal to 7.75 times 22. You can either use your head, a calculator, or a sheet of paper to multiply that out. But 775 times 22 should give you 170.5. Now, on a calculator, it would tell you 0.5. But now if you think back to what f of x is representing, again, in our problem, it says it represents your total earnings, and that is talking about dollars. So we would put a dollar sign with that. Thinking about money, money has two decimal places. So it's not just 170.5, it's $170.50. So we write that as 170.50. Great. Number 2 is just like that. So when you look at your notes today online, you'll see that that one is already answered for you. I'm going to go ahead and skip to number 3. If I were to make myself a little love note of one that I want to make sure I know and understand, number 3 would definitely be that problem. You will 100% see something similar to this setup on a test or quiz that you may have coming up. So looking at number 3, it says you were given a $50 gift card for CTA for your birthday, and each ride costs you $2.25. So the first thing it wants you to do is complete the table of values. Well, a good table always starts with the number of rides is equal to 0. So that's telling us what is our balance on the card that we were given for our birthday if we go on 0 rides. So our balance is 50. From there, we can go ahead and figure out the table for the next set of numbers. So you have 0 rides, 1 ride, 2 rides, and 3 rides. Without even making an equation, we can actually calculate that out. So to figure out the number of the number left on your card if you want to run one ride is you have that 50 minus 2.25. So if we go ahead and subtract that out, you end up with $47.75. To figure out how much is left after 2 rides, we're going to start at that 47.75 and we're going to subtract another $2.25. When we subtract that out, we get $45.50. Okay, so now to get how much is left after 3 rides, we're going to go ahead and do that same calculation. So we're going to take what's left, 45.50, and subtract 2.25 again. When we subtract that out, you end up with $43.25. Looking at that, that's a lot of work. And this is why making an equation would make things a lot easier. Say I wanted to know how much would be left after, I don't know, 10 rides or 12 rides. That would be a lot of calculations we need to do. So we can write an equation to help us better understand this. The first thing we need to do is determine what our variables are going to be. So if we look back at our equation here, we say $50 gift card, and it tells us that each ride costs $2.25. That each tells us who gets the X. And what is X talking about? That is talking about the number of rides that you go on. So number of rides that you go on, which means f of X is equal to what? Well, if you have a gift card and you're constantly taking money off of it, we want to know how much is left. We call that the balance. So f of X represents the balance left on the card. So balance on card. Now that we have identified what our variables represent, we can write an equation. So we're just going to go ahead. I think we could just write it. Maybe we'll write it right below defining our variables here. So we'll put it right over here. So our balance on our gift card, f of X, is equal to what? Well, how much are we starting with on that gift card? Correct. We're starting with $50. And if we are going down $2.25 every time you go on a ride, are we adding that or are we subtracting that? Great, we are subtracting that. So minus 2.25, and we said that that got our X, if we look back at our equation, because it says each ride. So that is our equation that we would use to solve the problems that come underneath it. So letter C is saying, what is the maximum number of rides you can go on before you run out of money on your card? If you notice with problem C, it's not telling us if we're putting X equal to 0 or f of X equal to 0. It's telling us that we run out of money on our card. So thinking about that for a minute, if we run out of money, meaning we have no money left on our card, is that talking about the number of rides, the X, or is that talking about f of X, the balance on the card? You guessed it, it's the balance on the card. This is like saying f of X, when is my balance equal to 0? So we're just going to take that f of X out of our equation and throw it out the door, and we're going to put a 0 in its place. So 0 is equal to 50 minus 2.25x. From here, we just solve our equations. So how do I move that 50 over to the other side? Careful, watch your signs. That 50 is positive, so we're going to subtract it to the other side. 0 minus 50 is negative 50, which is equal to a negative 2.25x. Again, carefully watch your signs here, because if you miss one small negative, you're going to end up with a negative answer, which is not possible. From here, how do I undo negative 2.25 times x? You guessed it, we're going to divide it. So divide both sides by negative 2.25. Kind of out of room, so I'll put it over here. So when I divide negative 50 divided by negative 2.25, I get a whole bunch of 2's. I get 22.22 is equal to x. Let's think about this logically for a minute. Can we go on 22.2 rides? No, you can't go on a partial ride. You either pay for a ride or you don't. This is where we always round down. So I don't have enough money to go on 23 rides, but I can successfully go on 22 rides. I can successfully go on 22 rides without going over the balance I have on my gift card. So 22 rides is the most number of rides that I can go on. So letter D is saying after you've purchased that number of maximum rides, how much money is left on your card? Well, now we need to go back and substitute 22 in for x. So f of not x, but f of 22 is equal to 50 minus 2.25 times 22. We want to know how much is left if we go on 22 rides. So if we either substitute that into our calculator or use our heads, we end up with 0.5. Again, if we're thinking about what does 0.5 represent, well, 50 cents is what it represents. So 0.50 is how we need to write it. How does that feel to you guys? Is it making a little bit more sense? Let's go ahead and look at one more example. So if we look at number 4 on the back side of your notes, it's talking about an amazing new store that's opening, and it sells everything you could ever imagine for just $20 for whatever it is that you buy. So $20 an item. That's right, any single item that you buy is $20. The only catch is you have to pay an initial fee of $50 as soon as you go into that store. So it wants us to write a function that represents the cost, and it tells us that f of x is my total cost, and x is the number of items that I have bought. So again, you're always going to start with the total of whatever it is. So f of x is equal to, okay, so as soon as you walk in that store, what do you have to pay? You guessed it, you have to pay $50. So there's my 50. What else do I have to pay for? 20 per item. So 20 per, that per word tells me that 20 gets my x. So if we're talking about how much total you have to pay that $50 when you walk in, and so plus $20 per item, so 20x. Now I've written my equation and I can figure out what the questions are that follows. Letter B says you bought 10 items, evaluate f of 10. So that means you need to take x's out of my equation and I need to put a 10 in its place. So f of 10 is equal to 50 plus 20 times 10. So if I buy 20 items at that store, how much money am I spending? Well, you either put this in your calculator or use your head, and you find out that you are spending how much? You guessed it, $250. Make sure you label your answers. So $250. Letter C is a little bit different because it's telling us that we spent a total of $670 and we want to know how many items were purchased. So remember, it told us that f of x represents the total cost. So if this was my total that was spent, I'm now going to do 670 is equal to my equation so I can solve whatever is left. So 50 plus 20x. This part is pretty much the same as what we've done in the past. So how do I move that positive 50 to the other side? I'm going to go ahead and subtract it. Great job. So 670 minus 50 is $620. That is equal to 20x. What is my final step before I divide, or before I get my answer? How do I get rid of that 20? You guessed it, I need to divide both sides by 20. And when I do that, I find out that x is equal to 31. Now, 31 means nothing unless you actually label what it's talking about. It told us that x represented the number of items that you purchased. So x is equal to 31 items. And that's all there is to these equations. Figure out who gets your x, and then ask yourself, is it giving me a starting value, or is it just whoever gets that x? If you have any questions, feel free to see your teacher. Otherwise, I'll talk to you soon. Have a good day. Bye.